All right, welcome. Picture this. It's your first day as a security analytics intern. You're in the Security Operations Center, the SOC, which is basically the digital front line against all kinds of cyber threats. And right there on your desk is your first major project. We're not just going to talk about it, you're going to build this thing step by step.
Okay, let's dive right in. So, every single SOC on the planet, and I mean everyone, faces this one massive, relentless problem: a constant, overwhelming flood of security alerts. Your mission, should you choose to accept it, is to bring some order to all that chaos.
And look, this isn't just some small annoyance. This is a critical vulnerability that we call alert fatigue. Just imagine trying to find one specific, important grain of sand on a massive beach. That's what it's like. When analysts get bombarded with thousands of low-value, repetitive, or just plain false alerts every single day, their ability to spot the real threats, the really sophisticated attacks, just tanks. They get overwhelmed, and the truly crucial signals get completely lost in all that noise.
So that's where you come in. Your mission is to go way beyond just collecting alerts. You're going to design and build an automated pipeline that can intelligently sift through that mountain of data, connect the dots between events, and push only the most high-priority threats that actually need a human's attention to the top. You're going to build a system that turns all that noise into actual insight.
Now, to succeed in this mission, you've got to master the two fundamental tools of threat detection. And this is not an either-or kind of deal. You really need to understand how they work together to create a defense that's way, way stronger than just the sum of its parts. So, on one hand, you've got the SIEM. That's the Security Information and Event Management System. Think of it as your rule engine. It is fantastic at spotting known bad behavior. For instance, you can write a super simple rule like, hey, if a single user has more than 5 failed logins in 1 minute, create an alert. It's fast, it's clear, it's super effective. But on the other hand, we have machine learning, or ML. This is the pattern learner. Now this is a totally different ballgame. ML doesn't rely on rules we write. Instead, it learns what normal looks like on your network, and then it flags anything that deviates from that baseline. You know, the statistical weirdness that could signal a brand new, never-before-seen attack. And that brings us to the core idea you really need to get. It's right there on the screen. Rules catch the known, while ML discovers the unknown. Rules are your shield against attacks we already know about. Machine learning, that's your radar for the threats you don't even know exist yet. And let me tell you, any world-class SOC absolutely positively needs both. So now that we have our tools, let's look at the blueprint. How do we actually assemble these things into a single, powerful, automated pipeline? This right here is your plan of attack. It all starts with raw logs, just tons of data from firewalls, servers, you name it. First, we have to parse and normalize them into a clean, structured format, so they all speak the same language. Then, that data flows into our SIEM, which uses our rules to catch the obvious stuff. Whatever is left over gets passed to our ML model, which then scores events based on how unusual they are. And finally, the whole system prioritizes the combined results and sends only the most critical alerts to the SOC dashboard for human analysts to actually look at. All right, enough theory, let's get our hands dirty. We're breaking your project down into 5 clear, manageable tasks. Just follow these and you'll have a working prototype of your very own intelligent alert pipeline. First things first, data preparation. And let me be really clear, this is the most important step. You know that saying in data science, garbage in, garbage out? It's 100% true here. You'll take a sample set of raw logs, could be from Windows, maybe a firewall, and your job is to clean it all up. That means normalizing key fields like timestamps and IP addresses so that every part of your pipeline can understand it. Your deliverable for this step is just that one clean, structured CSV file. Next, you'll build that first layer of defense, the rule engine. Using a simple Python script, or maybe a tool like Splunk, you'll write a few basic rules to catch that obvious low-hanging fruit. Remember that brute force attack example? A rule that flags any user with more than 5 failed logins in a minute is a perfect place to start. This becomes your baseline for catching the threats we already know how to look for. Okay, now for the really cool part. Adding the intelligence. You're going to use a powerful Python library called scikit-learn to build a machine learning model. We'll use one called an isolation forest, which is actually designed specifically to find rare events, those true outliers that your rules would totally miss. See, this layer isn't looking for a pattern you've defined. It's hunting for anything that just looks statistically weird or out of place. So, with both of your detection engines built, task 4 is all about connecting the dots.
You'll write a main script that automates the entire workflow. It's going to ingest the clean data, run it through your rules, then pass the leftovers to the ML model, and finally merge the results to export only the top alerts. This is where your project goes from being two separate tools to one single unified system. And finally, you have to make your findings useful to an actual human being. A long list of alerts is just more noise, right? So you'll use a tool like Matplotlib or Power BI to build a dashboard. And the goal here isn't just to make pretty charts. It's to tell a story with data, to create clear, actionable insights that a super busy analyst can understand in a single glance. So, after you've gone through all 5 tasks, what have you actually accomplished? What's the big payoff for all this work? Well, you've successfully built a machine that transforms a chaotic flood of raw data into focused, prioritized intelligence. And this just brilliantly illustrates the result. Instead of a flat list of, say, 10,000 alerts, an analyst sees this. They immediately know to focus on that critical 5%. Your pipeline has already done the triage for them, potentially slashing their immediate workload by 95%, and letting the human expert spend their precious time on what really matters: investigation and response. And your dashboard can do more, like highlight key indicators of compromise. A simple chart like this one, showing the top sources of suspicious activity, can instantly point an investigation in the right direction. This isn't just data anymore. It's a starting point for action. So the crucial point here is that by finishing this project, you haven't just built a tool. You've earned a new title and a whole new set of incredibly valuable skills in SIEM engineering, machine learning for cybersecurity, and automation. You've basically proven you can tackle one of the biggest challenges in any modern SOC.
But as we wrap up, this powerful automation brings up a much bigger question. As our machines get smarter and smarter at detecting threats, what's the role of the human analyst? Where does the machine end and the human begin?
And that leaves us with this one final thought to chew on. Your pipeline is brilliant at spotting statistical anomalies, things that just don't fit a pattern. But can it ever truly understand the intent behind an action? Or is it just a really powerful correlation engine that still needs a human mind to interpret the context, to understand the motive, and to make that final judgment call? That's the question that you, as the next generation of security professionals, are going to help answer. Good luck.